Section 4.4, Graphing a Function Rule. Graph the function for the given x values. Y equals 2x plus 3 for the values of x of -5, -3, 1, and 4. So these are the values we're going to plug in for x and see what we get out for y, and that's going to create our ordered pairs. So for the first one, we're going to plug in -5 for x. So we've got y equals 2 times -5 plus 3, which in this case, 2 times -5 is -10, plus 3 gives us -7. This means that our y value is -7 while our x value is -5. So that's the ordered pair -5, -7. Now we want to do the same thing with -3, 1, and 4. So you're going to plug in -3 for x, and you get 2 times -3, which is -6, plus 3 is -3. So this gives you the ordered pair -3, -3. Then you plug in 1 for x, and you've got 2 times 1 is 2, plus 3 is 5. So you've got the ordered pair 1, 5. And then you get plug in 4 for x, and you get 2 times 4 is 8, plus 3, so y is 11. So you've got the ordered pair 4, 11. And so these are our ordered pairs, and we want to graph these. And once we graph them, we'll be able to see the example of what our function rule looks like. So we put a point at -5, 7, -3, 3, 1, 5, and 4, 11. Example 2, we're graphing the function rule y equals x squared minus 3 for the values -2, -1, 0, 1, and 2 for x. So we'll do the first one together. Let's plug in -2 for x. You got -2 squared. I recommend putting this in parentheses when you put it in your calculator. Minus 3. So -2 squared is 4. 4 minus 3 is 1. So we've got the point -2, 1. We want to continue this for the other 4 values of x. So plug in the remaining values for x, and you should get, for -1, you get y equals -2, giving you the ordered pair -1, -2. Plugging in 0, you get y to equal -3. So you get the point 0, -3. And then for 1, you get y to equal -2. So you've got the point 1, -2. And then for the last one, you plug in 2, and you get y to equal 1. And so the ordered pair is 2, 1. And so the last thing to do is to plot these points. So we've got a point at -2, 1. So it's right there. We've got a point at -1, -2, which is right here. We've got a point at 0, -3. So there. Point at 1, -2, which is here, and a point at 2, 1, which is here. The next one, we're looking at graphing the function y equals the absolute value of x plus 2. And this time they do not provide us with values. Oh, actually they do, sorry, they're on the side here. They provide us with the values of -2, -1, 0, 1, and 2. And we're going to plug these in for x and see what we get. So for the first one, we plug in -2. So y equals the absolute value of -2 plus 2. The absolute value of -2 is 2, and then 2 plus 2 is 4. So our first coordinates are -2, 4. And we want to continue this pattern with the rest of the points. So let's plug in -1, 0, 1, and 2 for x and see what we get for y. So when you've plugged in -1, you get the absolute value of -1 plus 2 is 3. And so your point becomes -1, 3. You plug in 0, you get the absolute value of 0 plus 2 is 2. And so your point becomes 0, 2. Then for 1, you plug in 1 for x, you get the absolute value of 1 plus 2 is 3. So y equals 3, giving you the point 1, 3. And last but not least, plug in x is 2. The absolute value of 2 plus 2 is 4, so you have the points 2, 4. And so the last part of this problem would be to graph it. So we're going to graph these points to see what our function rule looks like. So we've got negative 2, 4. It's slightly off the graph here for me, so I've got to graph it up here. And then negative 1, 3. There. And 0, 2. And then 1, 3. And then 2, 4. It appears our graph makes kind of a V shape here, which is true for the absolute value. It should make kind of a V. In the last example, they're giving us the function rule y equals 3x minus 2, and they want us to plug in the values of negative 2, negative 1, 0, 1, and 2 for x. Go ahead and pause the video, try this problem on your own, find your x and y coordinates, graph the function, and then unpause the video and see if you get the same answer I do. So after plugging in the appropriate values, you should get the points negative 2, negative 8, negative 1, negative 5, 0, negative 2, 1, 1, and 2, 4. And then your graph should look as it does on the right. So now we're going to talk about the idea of continuous and discrete graphs. A continuous graph is a graph that is unbroken, meaning that you would graph the values in between whole numbers. So think of continuous graphs being like you can have decimal points or partial items. So if you're talking about time, you can have seconds, milliseconds, and all of those smaller values, so it would be like fractional pieces. Where discrete graphs are composed of distinct isolated points, or they're talking about things that can't be broken apart, like people or cars or cans of soup. You're not going to get 0.25 cans of soup when you go to the store. You're going to get 1, 2, 3, or none. So that's the difference. Continuous are things that can be broken apart, where discrete are things that cannot. So in this, they ask us to graph each rule and determine if the graph is continuous or discrete and justify our answers. We actually don't have to graph these to give our answers. So let's just read the situation and see what happens. The amount of water, W, in a wading pool in gallons depends on the amount of time in minutes the wading pool has been filling, as related by the function rule W equals 3t. So they're talking about two different values here. They're talking about gallons of water, and they're talking about time in minutes. So in both cases, gallons can be broken apart into smaller things that make up gallons, like cups, pints, and all of these things. You're allowed to have partial gallons. You're allowed to have half a gallon, a quarter of a gallon. So that sounds more like continuous than discrete. Same thing for time. You can have seconds and half a minute or a third of a minute. So this is going to definitely be a continuous graph. We would graph this with a complete line as opposed to dots. In this problem, they're talking about the cost of baseball tickets in dollars. Depends on the number of tickets bought, related by the function rule C equals 16n. When determining discrete or continuous, the big thing to look at in this case would be the tickets, which in this case, the tickets themselves, or the number of tickets there is your independent variable. That independent item determines everything else. So when you buy sports tickets, you have to buy full tickets. You can't buy half a ticket. You can't buy a third of a ticket. And because you can only buy whole number tickets, this graph is going to have to be discrete, meaning that it's going to be dots as opposed to connected line. And then last but not least, Megan buys eggs at the supermarket for $1.75 per carton. The cost is a function of the number of cartons bought. Graph the function and tell whether it is continuous or discrete. Once again, we don't have to graph this to tell whether or not it's continuous or discrete. We have to think about when we go to the store and we go to buy eggs, we're not allowed to just randomly choose 3 eggs from the carton that we want and that's it. we have to buy the whole carton or no carton at all, or we go to a smaller carton, which is still considered a carton. Because you're forced to buy whole numbered items or whole numbered cartons, this is going to be discrete as well.